Hello and welcome to another Monday night Q&A. I'm joined tonight by one of my colleagues from the field assessment team, Craig Hawkins. Good evening, Craig. How are you?
I'm very well, thank you. Yourself?
Yeah, not so bad. How's your Monday been so far?
It's been very good. I've had a good contractor today, so it's always good to start your Monday off well on a good week.
Fantastic. Yeah, so Craig's one of our assessors, so out in the real world assessing our registered and applicant contractors. My name's Sam Donaghy. I'm the team leader for the technical helpline team, looking after the telephone lines and emails. As with all of our live Q&A sessions, I'll just run through a few house rules. So we'll start off with the question of the week, which we posted out on social media earlier today, and run through the answer of that question. And then we'll leave you some time to put your questions into the chat. So please do that. If you've got questions which you'd like us to attempt to answer tonight, please post them into the chat. And we'll while you're doing that, we'll go through some of the questions that we didn't get round to from previous sessions and give you our answers to those. While you are putting your questions in the chat, please remember there's no such thing as a stupid question, only stupid answers. And please also remember to be respectful to each other in the chat. We don't mind you talking to each other and helping each other out, but please be respectful, as the whole idea of the evening really is that collectively we're going to help each other out with the aim of improving our collective knowledge and understanding of BS 7671 and all of the electrical world. Okay, so without any further ado, I'll just remind people of what our question of the week was. So yeah, a little bit of maths, but I think a very useful question for those that perhaps were a little bit unaware. So, if a ring circuit wired in 2.5 1.5 mil twin and earth had a little R1 of 0.52, what would you expect the R1 plus R2 to be for a socket at the centre of the ring? So we've got a ring circuit wired in 2.5 1.5 mil, pretty common for domestic type scenario. The R1, which would be the end to end of your line conductor, measured 0.52, and then while you were doing the continuity of circuit conductor tests, what would you expect your R1 plus R2 to be at a socket which was at the centre of that ring?
So this particular question requires us to do a bit of maths, as Sam said. So first of all, we need to understand that the cross-sectional area of copper coordinates and changes depending on the resistance of that cable depends on the cross-section area. And because the cross-sectional area of the 1.5 of the CPC is smaller, it means the resistance will be greater. But there is a correlation between the cross-sectional area and the resistance. So to work that out on a 2.515 is that you take 2.5, you divide it by 1.5, and you get a value of 1.67. Now what that means is there's a correlation or difference between your 2.5 resistance and your 1.5 resistance, and you multiply the R2, so the little R1, by 1.67, and that should give you the likely or intended value of your end-to-end test result of your CPC, which equates to about 0.87. Now, for some of you that might be doing 4 mil ring circuits, that value is different, so we probably hear of the 1.67 multiplier. On a 4 mil 1.5 ring, it's actually 2.67, so it's slightly higher. Now, that is, then we've got to look at doing step 3 of your continuity test, your R1, R2 test. And it's what we generally call the figure of 8 test, what most electricians do out in the real world. So you're crossing over your line of your incoming cable and your CPC of your outgoing cable. So crossing those two legs over, and you do the same for the outgoing line of the incoming CPC. And then to do the maths to work out what the intended value is in the middle of that ring, is you take the sum of your R1 and R2 and divide it by essentially the 4 parallel paths that you now have. So it's R1 plus R2 divided by 4. So we have 0.87, which is the multiplication of 0.52 by 1.67. And then you divide that by 4, which gives you a value of 0.35. So the answer to the question is B, 0.35 in this case. Anything to add there, Sam? Pretty happy with that?
Yeah, no, that was spot on and nicely explained. I tried to follow your explanation, which was absolutely perfect with the slides. So yeah, and it's a useful thing to know, because I think one of the things was, I don't know whether it's still done, but the way I was taught was we were taught how to test first, and we did that. So you could do the test, you could do step 1, step 2, step 3, and you could record the values in the right boxes. But then it was the light bulb moment when I got taught, yeah, but what do I check those values against? So that was the key of testing. You know, it's not so much physically being able to do the test and record it in the right place, but it's the interpretation and the validation, and is that value correct? Is it compliant with 7671? Is it safe? Is it what I was expecting? If not, why not? So it's that validation bit, and that little rule of thumb calculation, R1 plus R2 over 4, tells you what you should expect at that midpoint. So that's how you can do that sanity check of, okay, I've got a measurement. Is that what it should be? So spot on.
It is worth noting that in the on-site guide and the guidance note 3, there are tables which give you the milliohms per meter of a length of a conductor. So normally 1 meter. So you can multiply that by what your length of your cable is. We also have a pocket guide, so we'll advertise that as well. And we also have our pocket guide app that's got a calculator for this as well, that can actually help you to determine what your intended result would be given that length of your cable. And I was slightly different with my training, Sam. We actually did the maths first to see what values we are likely to get and see if your test proves that. So we have a hypothesis, and then we prove the hypothesis, was how I was taught. But then again, they both meet to the same requirement, and they both meet to compliance with 7671.
Yeah, no, absolutely, and it's a great point that you raised, that if you know the cross sectional area of the cable, you know the length, you should have an idea of what your resistance is going to be, or vice versa. If you know the resistance in the cross sectional area, you should be able to estimate the length. As you said, that's a little feature of our freely downloadable app, which you can download for your phone, and it will give you an idea. And it's a great validation check, isn't it? If I've installed and I've done my design, I know what the cable run should be. So again, it's something else that we can verify, that we have got the right length of cable, it's not been damaged, perhaps there's not loose connections. We can start to then investigate a little bit if I don't get the right value. So yeah, no, that's a really good point, that it's all about validating that result. What does that actually tell me? And it will tell me, as you say, an approximation of what length of cables I'm talking about.
And make sure you know your leads and take into consideration that you might have some contact resistance on your socket adapter, your socket outlet, or your switch on that socket outlet as well. That might give you a slightly higher than expected reading, but at least take that into consideration when you're actually doing those tests in the real world.
Yeah, okay. Right, I'm starting to see some questions coming into the chat, which is brilliant. Thank you for that. While we're waiting for those to come in, we'll just have a look at a few of outstanding questions. So one that we had before was, when installing an item of equipment, does the electrical contractor have to follow the equipment manufacturer's instructions? What's your thought on that one, Craig?
So we have a regulation for this. It's 134.1.1. And it states in there that the installation of electrical equipment so it is a normative regulation, but then the rest of the wording says take into account of manufacturer's instructions. So we must take account of what the instructions say, but that doesn't say that we blindly follow them. Now, this is a change, not a recent change, that being said, but it was a subtle change in Amendment 3 of 7671 back in 2015. So it was actually the 17th edition. And it changed the wording from electrical equipment shall be installed in accordance with the provided manufacturer's instructions to the fact that we should take account of the instructions as well. So from Amendment 3 of the 17th edition onwards, it's actually taken into account the instructions. So no, blindly following the instructions.
Yeah, absolutely. So it was, as you said, it was a subtle difference to just to clarify that if you, as the electrical contractor, with the knowledge that you've got of the installation and the equipment you're installing, don't believe that the instructions are correct for your installation, then for compliance with 7671 you don't have to follow them. So it says take account. I mean, in those situations we would always recommend you go back to the manufacturer for clarification, especially where you're considering that it would be better, i.e. compliant and safer, to not follow a particular point in the instructions. Always go back and seek clarification, but it has changed that regulation to confirm that you don't actually have to follow the manufacturer's instructions in order for your installation to be compliant with 7671. Another one while we're waiting is something that we're seeing perhaps more and more. When installing a 3-phase consumer unit in a domestic installation, can I still use 6 kA rated circuit breakers, or do I need to use 10 kA rated ones? So it's a 3-phase installation which we're seeing more and more of now. In a domestic scenario, do I use 6 kA rated breakers or 10 kA? What guidance can we give there, Craig?
So this is really dependent on the prospective fault currents that are measured within the domestic installation at the relevant points where the circuit breakers are to be installed. It is worth noting that the braking capacity on the side or the front of a protective device is the maximum fault current which that circuit breaker can successfully and safely interrupt without becoming damaged. So generally, domestically, we tend to use 6 kA rated circuit breakers, and 10 kAs are generally for non-domestic installations. But that's a rule of thumb, but it's not a requirement that we have to follow. But there is guidance in 7671, 434.5.1, states that except where the following paragraph applies, the rated short circuit braking capacity of each device shall not be less than the maximum prospective fault current at the point at which the device is installed. So a lower braking capacity is permitted if another device or devices have the necessary rated short circuit capacity installed on the supply side. So prior to that device in the electrical installation, if there is a device that can deal with that level of fault current prior to that, then the compliance with the regulations have been achieved. And that's only when the let-through current of that device is sufficiently low enough to stop the device further down the installation, such as your 6 or kA breakers in this installation. But there's also another regulation, which is 434.1, and it states that the prospective fault current shall be determined at every relevant point of installation. Now, determined doesn't always be measured. It can be calculated, or it can be obtained through inquiry as well. We also have Appendix 14, which provides some further information regarding to determining the prospective fault currents at every relevant point of the installation, which includes locations where switchgear devices may have to operate to disconnect a fault as well.
Yeah, so basically we're saying there is no blanket that says for this type of installation use this size, for this type use the other size. There's no concrete definition. It does depend very much on what your prospective fault currents are. So first of all you need to determine then, and then select the correctly rated protective device so that it's going to operate safely and not cause any damage to itself or its surroundings. So yeah, Appendix 14 is some good informative information that tells you and gives you some examples of where, at what points within the installation we should be looking at that. We'll take one more of the old ones before we delve into the new. Selectivity. In instances where we've got RCDs in series, what do we need to do to make sure that we achieve selectivity between the RCDs in series, Craig?
So we're looking at having time-delayed RCDs being upstream of the non-time-delayed. And the ratio of the upstream RCD to the downstream RCD should be at least 3 to 1. So we're looking at, if you have a 30 milliamp protecting your outgoing circuits, then upstream of that, then you're going to be looking at 3 to 1 to that, so anything above 90, so you'd be looking at 100 milliamp in that regard. So 536.4.1.4 states that selectivity in any case of residual currents are shown in the figures 536.2, and it is given under the following conditions. So the upstream device is selective type, so a type S, which is a time delay, or time delay type with appropriate time delay settings, and it says on there that the ratio must be 3 to 1. So it's to make sure that in the event of a fault, I'm not sure if the figure is shown on the screen here, but if the fault is present on the load side of RCD21, that the upstream device of that would therefore shouldn't operate under fault conditions because it has selectivity, correct selectivity, and it shouldn't operate. The one closest to that fault should operate before the upstream one does.
Yeah, thank you. Okay, we'll take a look at some of the questions that have come in from the audience. So thank you very much for those. Please keep pouring them in. So the first one we've got off the block is, can we still make additions or alterations in brackets or a new circuit in an existing PVC consumer unit without the provision of an SPD? So we'll take it in two parts really, but if we're looking at the idea that the consumer unit is still plastic, then yes, we can make additions and alterations to that board without having to change it to a non-combustible enclosure, but it would be a recommendation to consider that. So have that conversation with the installation owner about the advantages of a non-combustible enclosure. But you can add circuits, you can alter and add to the existing circuits without having to change the board to a non-combustible enclosure. I'm assuming that we're talking about domestic installations here. So we can do that. Without the provision of an SPD would be the second bit, and then it very much depends on what you're adding. So for example, if you were adding a circuit which falls into the definition of a safety service, then for compliance with 7671 that circuit would need SPD protection, and ultimately the installation or the consumer unit feeding that circuit would need a degree of SPD protection. So it does very much depend on what you're doing. New circuits, everything that you do with the new circuit needs to comply with current regs, assuming that it was designed after September 27th. So you would need to consider all of the requirements, whether that be SPD or not, but it's generally not a requirement to upgrade an existing PVC board, providing it's still fit for purpose, i.e. provides all the correct barrier and enclosure requirements, there's no signs of overheating internally, so everything looks to be okay. It's just the fact that it's PVC rather than metal. Would you add anything onto that one, Craig?
I'd probably add in relation to the level of tolerable risk for that additional circuit, in relation to the customer being happy that particular circuit will not be damaged in the event of a surge or an over voltage, and if it is possible that they are happy to accept the level of tolerable risk for that additional alteration.
Yeah. Another one that's in the chat is when adding extra smoke detectors on an existing circuit, does it require an SPD? Well, strictly speaking, so the letter of the law is that I shouldn't use that term because 7671 isn't actually statutory, but 7671 defines smoke detection as a safety service because it's something that will warn people of an evacuation requirement. So as with other additions and alterations, if you were adding to a safety service. Strictly speaking, only your additions need to comply with the regs at the time that you're making your addition, but in reality and the practicality is that if you wanted to protect those, you would have to protect the circuit feeding them, and possibly then the supply to the board that's feeding them. So you may have to go all the way back to the origin of the installation, but yes, you would need to provide the requirements of 7671 Amendment 2 for the addition, but in practical terms that would actually mean that you're providing it for that circuit supplying it. Similar theme, Craig?
Yeah, similar thing for that as well.
Okay, another one, common question that we're getting on an EICR, what code are we putting down for a type AC RCD on a domestic installation? I'll highlight at this point in time the RAG questions on Electrical Safety First website. So for those people that aren't aware, Electrical Safety First have a wiring regulations advisory group, which is made up of a number of industry recognised bodies, including the NIC and other competent person scheme providers, and BEMA and the IET and City and Guild. So you can have a look on the Electrical Safety First website who's involved, and this is one of their frequently asked questions. The bottom line is that unless there's any evidence of that type AC not functioning correctly, then there's no requirement to give it an unsatisfactory code. Obviously, if there is evidence, if you can prove that it's not working correctly, then you need to consider what is it there for. Is it just providing additional protection, or is it providing fault protection, and then code it accordingly. But again, there isn't a blanket statement, but what we'll try and do while we're having a wash up at the end is I'll try and pull up the website information where you can go to that bank of frequently asked questions. There's actually two banks of questions, very useful. One's concerning new installations, and one's concerning the test and inspection of existing installations. So those are freely available. It's a freely accessible website. There's no requirements to access those, and as I say, they're industry recognised responses to common questions and answers. Type ACs, I mean, we're seeing a lot of those that were previously installed. What's your thoughts on that on an existing installation, Craig?
So when it comes to any observation of on an EICR, it's the analysis of risk. So we although we have industry guidance which gives an observational code, a generic code that we might have for a particular observation, it is the analysis of risk and how likely that is going to cause damage, danger, deterioration, and how the engineer makes a judgment call on that particular installation. As you said, Sam, what is the RCD used for? Is it there for fault protection? Is it there for additional protection? Is there evidence that that is being blinded by some DC feedback or some description? Is it becoming inoperable? And if the evidence is not there to declare that or determine that that is being blinded by any potential DC currents, and it is operating as intended to, how can we be asked to give that a code that isn't anything but satisfactory? Which is why the RAG, as Sam said, is there and determines that. Coding of EICRs is very subjective. It's always a very good conversation that I have with contractors when I'm out in the field, and I always direct them to the BSF's best practice guides and the RAG Q&As, because it is such a handy tool for you to have in your arsenal to go, you know what, I'm not sure about this and I want a bit more information, and it's out there freely available for you guys.
Yep. Okay, another interesting topic, diverted neutrals. Any recommendations to contractors on how to deal with it? I think the first thing, and probably the most important thing we would say, is to if you've got any suspicion about an installation receiving diverted neutral currents, that you need to contact the distribution network operator as soon as possible, because that's an indication that if it is diverted neutral currents, you've got a fault somewhere in the distribution network, and you may not be the only installation that's being affected by that. So it's very much a case of it's very highly unlikely that it's something that you're going to be able to resolve. So you need to get involved with or make contact with the DNO. Tends to be that they'll, if we're talking about from a domestic supply, they'll want to know that you've got the owner's permission to do it. So that's a good source to start with. But yeah, you know, if you've got an indication, for example, you've got everything off in your installation, so you know that there shouldn't be anything coming in, and you're seeing currents enter your installation, most likely through things like extraneous conductive parts, that could be an indication that you've got a possible fault in the distribution system locally. So yeah, involve the DNO would be the biggest. Make as much or gather as much information as you possibly can, so that they're as armed as they can be when they do come out. But yeah, it's something that, especially if we're talking about high currents, you would normally take care of things a lot of the time at the origin. But if these are actually coming into the installation via extraneous conductive parts and not via the origin, then it can cause problems within the installation. So yeah, get the DNO involved. Anything else you'd add to that, or any examples from your experience, Craig?
So when you're determining whether or not something is a diverted neutral current, be careful you're not confusing that with earth leakage currents as well, because the way that you determine diverted neutral currents is generally with a clamp meter or a earth clamp meter as well. Is that sometimes when the installation is in service and you're using it and you're trying to clamp to see where the current is flowing, that could be an indication that you've got some earth leakage going to parts of your installation from the equipment that you have installed, which is in some situations an inherent part of that piece of equipment anyway. Computer systems and stuff, if you've got loads of them, then there is higher leakage currents on those. Yeah, just be careful. You know, don't always assume that when you're disconnecting an earthing or a bonding conductor that you think that is particularly a safe conductor, because as Sam says, if you have a diverted neutral current and you think the installation is off, you could still have high currents, or reasonably high currents actually, between your earthing system and your main bonding or your bonding conductors. And so there could be currents across there, so do be careful when you're out in the real world with that. As for dealing with them, as Sam said, talk to the DNO. There are situations where because of diverted neutral currents, there are types of installations where we actually don't have PME supplies. Hazardous areas, petrol filling stations is one of them. Generally speaking, we don't permit them to have PME supplies, generally speaking.
Yeah, because the concern is obviously if you've got a PME supply and you've also got a lot of ground metal work, so we've got metal structured buildings, for example, which we will get, then the concern is that all of those extraneous conductive parts resulting from the metal structure into the ground are going to act as a nice conduit path for any diverted neutral currents that might be in that locality. So yeah, something to consider. Quite a long question, but I will take it because it's fortunately it's perhaps a shorter answer than the question. So one of the engineers online tonight has asked, when assessing or auditing members, do the NIC check that your members have in place and are following safe systems of work when live working is deemed necessary? A common activity when testing, however, does everyone abide by electricity at works regs when equipment is not IP2X or other risks are present? So yes, part of our assessment of certified contractors and also applicants is making sure that they work safely. We'll go through things like ensuring that they've got the right equipment, that they've got, if they're not a sole trader, that they've got lock-off equipment. We're ensuring that they can do safe isolation. We're ensuring that they're aware and have knowledge as required for their scope of work with regards to electricity at work regulations. So it is part of our assessment process. I mean, Craig is involved in assessments on a day-to-day basis, so perhaps we'll be able to tell you a bit more. But yes, it is, it's one of the fundamental principles. We don't do anything else on an installation until we can ensure that the person knows how to do, for example, safe isolation to start with, and that prior to that we will have checked that they've got adequate equipment and it's in a serviceable condition. So yeah, it is a key part of the assessment process. Would you add anything to that, Craig?
No, I think you're spot on there, Sam. There are situations where assessment calls for the QS may be able to demonstrate technical knowledge of how to demonstrate safe working without physically demonstrating it. As an example would be if the contractor can explain to me the process of testing, the purpose of testing, and the intended test results on, let's say, a lighting circuit on some outdoor lighting that are on columns. I'm not going to want him to shimmy up that column or put a ladder up there or get a cherry picker to maybe do a ZS test and exposing himself to live parts for a test that I've determined that he knows how to conduct, when to conduct, and why to conduct. So we follow the Electricity at Work regulations and the Health and Safety at Work Act during the assessments, and it is a holistic approach. It doesn't have to demonstrate every single test every single time. It's about making sure that QS has adequate competence and knowledge to conduct their role as an effective QS, including safe isolation, locking off as required, proving dead, and conducting tests as per BSN 671.
Yeah. Okay, so there's some chat. I'm just trying to pull the questions out of. One of the engineers talking about using R2 to find the centre of a ring, which is also possible. I think going back to our original question. Will Electrical Safety First stand up in the court of law and support that advice? Well, I can't speak on behalf of Electrical Safety First, but it is, if we look on their guidance on the RAG, that's the guidance they give. I think that this is referring to the advice about type AC RCDs being installed. Do contractors need to ensure more to cover following the AC RCD advice? It's difficult. We would, one of the things that we would add is that they need to look at what's that type AC circuit actually supplying. But often that may not be known. We might be looking at a void residence where there isn't actually anything plugged in or use at the moment, and then it would be advisable to record the fact that it is a type AC and therefore isn't DC tolerant above the defined degrees by the manufacturer. So other than that, there's very little more that we can do. We're certainly not saying that all the AC types that are currently in existence need to be replaced. We see that as way too onerous the other way. So all that you can do is make your inspection and test based on what the installation is at that moment in time. If it is an installation which is currently being used, then you can talk to the owner about what does get plugged in if it's not plugged in at that moment in time, and how is it used, and pass on information about checks to ensure that, as we talked about right at the beginning, manufacturer's instructions, if they're using items of equipment where the manufacturer is talking about the need for having a DC tolerant RCD to protect it, then that's a consideration that the user should ensure gets taken through. But yeah, we would, as the NICIC, stand behind the advice that we've contributed to, which is on Electrical Safety First website.
And as Sam said, it is guidance. It is there to help engineers out in the real world to come to a conclusion on observation code that they might want a bit of advice on. And at the end of the day, if as the engineer standing in front of that job, completing the condition report, it is your engineering judgment to decide what the observation code is, and then that you must justify that code and a rationale as to why you've given it possibly a C1, a C2, a C3, or an FI, or left it as an NA. Yeah, it's your responsibility as that engineer to do so. And as I said earlier, it is the analysis of risk. If there is no evidence to say that RCD has become inoperable, and it's been like that for 10 to 15, 20 years, who's to say it would be inoperable? If it's not there today, and it's not there tomorrow, it's not there the day before, there's no evidence to be able to say we need to change these RCDs to A types, because there is no evidence of that as we currently see it, and that snapshot of time when you're doing a condition report.
A few questions about when will Best Practice Guide 4 be updated to Amendment 2 and available. We believe that it's imminent. We're waiting for it as much as everybody else, just to get clarification and confirmation on some points. So we're hoping that it will certainly be in the next few weeks rather than months, but we don't have a definitive date, unfortunately. Engineer has replied, ramp test, again I think we're talking about AC type RCDs. Ramp test before any work will tell you if it's being blinded, it won't trip on 1 times I delta. So yeah, I agree, ramp test, very useful test for confirming whether it's working or not. However, that will only be relevant if the load which is possibly causing the DC current is also active at the same time. So sometimes we might do a ramp test when that load isn't on, and get a completely different answer to what we would do when it is on. So I think it's more a case of do the required test on the RCD and then do your investigation regarding what loads are being supplied from that circuit. What level of inflow current would you consider reportable to the DNO? So I think this is when we were broaching the subject of diverted neutrals, and typically I think as Craig referred to, you'd be looking at you'd be looking at quite substantial currents flowing in. Normally we'd pick them up on bonding conductors, where we wouldn't expect anything. If our installation was healthy, we wouldn't expect any current to be continuously flowing in the bonding conductors. If we're seeing that, then I think that's something that then we would need to try and investigate where the source is. If you then can confirm that the source isn't within your installation, I would say that's the point then at which you want to start involving the DNO, because it's possible that it's coming either through their transmission network, or it's coming from a fault in another local installation. But again, depending upon where you are, you might be able to determine that that's not possible. For example, if you're out in a very rural location, then the only other type of installation which could be influencing yours may be the network. Regarding meter cabinets, I came across a lot of occasions where there is single insulated cables terminated into the Henley blocks. Where do we stand on coding it? Well, in general we talk about single insulated conductors which can be touched as recommend that they are coded as a C2, because we're relying on a single layer of insulation, and if they can't be touched, in general as a C3. When it comes to meter cabinets, then it's very dependent on the status of that cabinet. So if it provides an adequate enclosure, then it's no different from single insulated conductors which we've got in other enclosures like the consumer unit. So it does very much depend on the state and condition of the enclosure and its locking mechanism, and the condition of the terminations within it. So have they been well terminated so that there's minimum or no copper showing outside of the contacts, and it is just the fact that it's single insulated cable, and if that's in good condition, then because that's within an enclosure, that's deemed adequate.
Especially where you can only access it through the use of a key or a tool.
Yep. Someone asking for clarification because they may have missed it for a while. There seems to have been a change of opinion from previous Q&A sessions around smoke detectors in domestic properties being defined as safety services. I think this is right now. We have to say that the definition in part 2 of 7671 clearly would include domestic smoke alarms. We are seeking clarification because we don't believe that was the intent of the regulation to perhaps limit the expansion of domestic smoke alarms. But right now, as of this moment in time, then we would have to agree that safety circuits would include domestic smoke alarms, and therefore all the requirements of safety circuits, including protection against transient over voltages, would be required. So that's the engineer that I'm responding to. Can you confirm or elaborate at that moment in time? But as it's something that we are talking to people about, because we don't believe that was the original intent of that regulation. How long do we think before wiring ring mains as we know it in the UK will be no more, and will 4mm radials be the replacement? That's a question that's been going. I started this long windy road in 1978, and I'm sure it was being asked in the early 80s, if not before. So it's something that will, and if you look at the history, it was done when there were things about copper shortages just after the war, etc. So there's nothing in 7671 which excludes them. There's not many countries around the world that use ring final circuits, and all of those tend to be ones that have been influenced in the past by the UK. And lots of people are choosing to do everything in radial because it's a lot easier to test and fault find and discriminate, and it doesn't have some of the disadvantages that a ring circuit would have, i.e. being fault tolerant when there's a break. So there's nothing. We're not aware of any plans to rule out ring final circuits for compliance. There are additional requirements in 7671. Lots of people saying that they should be banned, but there's nothing in 7671 as yet. When I say lots of people, I meant lots of people in the chat tonight saying that they're not happy with them. Okay.
I would say from an assessor's perspective, I've not seen a huge decline in the use of ring final circuits when I'm out on assessment. I have seen more frequently used radial circuits, but I wouldn't say there's been a massive, huge decline of people not installing ring final circuits. They had their merits, they had their benefits, as Sam talked about. They were brought about due to a copper shortage. You can achieve the same level of compliance with a radial that you do with a ring final circuit. So as long as you're complying with the relevant parts of 7671 that are in relation to ring final circuits, they are still suitable, they can still be used, and they are still being installed to this day. So, because they've been about since, the end of the Second World War, so, from 1945 onwards, or there or thereabouts, so let's say 1950s, or 70 years since then, it's quite a significant amount of time for us to then suddenly just go, nope, we're going to stop them and ban them. Or imagine how many houses would need to be supposedly rewired then, because you've got rings, which just wouldn't be the case. If you've installed a ring final circuit adequately and safely, it complies.
Yeah. And so, same engineers made the very valid point that 7671 is minimum guidance. Well, I think the way that we say it, 7671 is what you need to meet for compliance with the British standard. Yeah, but there's nothing to stop you going over and above that. It is a minimum. It's the minimum that we assess to in terms of our electrotechnical schemes. So yeah, there's nothing to prevent organisations going over and above that, but while they comply with 7671, then they're compliant with the standard for electrical installation. Some people talking about the 80% rule. So our designers at work design circuits to 100% maximum earth fault loop impedance, resulting in many circuits failing the 80% test. One said that they'd never heard of the 80% rule. Do we as a QS need to insist these circuits are altered to please the 80% rule? So the 80% rule is all about the fact that when we're doing our initial verification and also periodic inspection and test, we'll be measuring the impedance, the resistance of those circuit conductors under no load, and under no load they'll possibly be colder than they will be while they're running current. And therefore that temperature difference will also have an effect on what the actual impedance and resistance of the conductors are when they're operating under normal conditions. So as a rule of thumb, as an approximation factor, we work on that 80% value, that when we measure the conductors cold, we should be achieving 80% of the maximum ZS for the protective device if we're looking at using automatic disconnection supply as our means of protection against electric shock. So yeah, they can design the circuits to 100% earth fault loop impedance values, but they need to then bear in mind that the resistance changes depending upon temperature, and the temperature of the conductors will change with current loading. So that needs to be fed down to the inspectors and vice versa, so that when people do those calculations, they're going to get still compliant resistance values when they're measuring cold and comparing against the 80%. Lot of confusion out there about 80% values and why we test to them, Craig, or do you think it's pretty much nailed now?
I think most contractors I go to understand the 80% rule. They see when their forms automatically fill is at the 100%. But it says engineers that we need to understand that 80% is, as Sam said, is under low conditions your resistance increases, so therefore you may not achieve your maximum ZS value of that device if your device is, when you've measured it, as above the 80%. That being said, there are situations where that cable, especially on much larger cables doing much lower loads, maybe you had to install a much larger cable through volt drop as an example, that cable is unlikely to reach a higher temperature under those significantly small loads for its rated current. That your 100% is what you've worked to, because the 80% is that rule of thumb, and it's in the appendices, so it's not a normative requirement, it is informative. But part of my previous career I worked in street lighting and infrastructure, and a lot of those cables are sized because significantly long run means you have significantly large cables due to volt drop, but the actual load going through that cable is extremely small in comparison to its current carrying capacity. And therefore, when actually under low conditions, it's actually not raising the temperature to a significant amount that it would increase the resistance of that cable beyond at 20% of that resistance. So it's not a one size fits all. There are situations where you might have high current loads nearing its operating temperature that could increase the temperature to a point where the resistance is such that it increases past its 100% value if it's been measured at 85% as an example.
Okay, thanks. Once again, time has run away with us. Either that, or I can't tell the time, or keep to time. So we'll bring things. Just last question Does the isolator for a domestic bathroom extraction fan need to be located next to the fan? So does our isolator need to be in the bathroom next to the fan?
No, but it must be suitably placed. So one of our fundamental principles, 132.15.201, states that effective means of suitable places for ready operation shall be provided so that all voltage may be cut off from every installation, from every circuit thereof, and from all equipment as may be necessary to prevent or remove danger. So it must be suitably placed for ready operation, which will depend on a number of factors, including the associated hazards and using of the installation. We have another regulation, 537.2.7. Each device device used for isolation shall be clearly identified by position or durable marking to indicate the installation or circuit it isolates. And therefore, if the isolator is not local to the fan, then it should be identified by durable marking. So, as an example, and I see this quite often in assessments, you might have an inline fan in a crawl space or a loft space. I mean, your isolator being external to the bathroom, and if I want to work on that for isolation purposes, that becomes incredibly difficult because I've then got to turn it off. Not all of them are lockable, so I won't be able to use that for isolation for electrical isolation, because then I've got to get in the loft to work on the fan. So there are situations where, depending on the fan type, it is advantageous to have it next to the fan and advantageous to not have it next to the fan. But no, there is no requirement to have it next to the fan. It must be suitably placed and adequately marked if required to do so, if it's not in a location that is obvious for its use.
Yeah, thank you. Okay, just want to tell the audience about some upcoming webinars which we have. So next week we've got a webinar about the requirements for installing AFDDs, and then a fortnight after that we finish off the wire webinar series for this year with an introduction to prosumer installations. As also make you aware that as well as those live ones, we've got a large number of on-demand webinars which are available for you to watch at your own time, and they're already uploaded onto the NIC website. We mentioned it earlier when we were talking about the R1, R2 measurements and comparison of conductor resistance to length of cables. We've got a freely downloadable pocket guide, which, as well as including all of the old pocket guide information, actually has some free calculation tools on it, one of them which enables you to do that validation of conductor size, cable length and resistance values. So if you haven't already downloaded your free version of the pocket guide, please do. Thanks very much for those people that contributed tonight. I hope those that put questions in feel that they got answers. We will take a trawl through the questions after the webinar tonight is over, so that we can pick up any that we haven't answered and perhaps go back on those in the next session. So please do keep putting questions in, and if we didn't get round to your question tonight, I do apologise, and we will try and do that in our next session. That just leaves me lastly to say thank you very much. I think everybody again, I always like it when I keep an eye on the chat and people are helping each other out. That's the whole purpose of these Monday night Q&A sessions, is to help each other out, and I can guarantee that if we do that, we'll all learn and benefit from it. So yeah, please do, if you haven't already, sign up to join us on the next webinar, which is next week. And if you can't make that, watch it on demand, and in a fortnight's time we'll do another one of these Q&A sessions where we'll try and take as many questions as we can from the audience and answer them for you. Another super fast hour of your life, Craig. It always is the fastest hour of my working life. These are, it's unbelievable. It starts off in the first 10 minutes I'm panicking that we're not going to get any questions in, and then by the end of it it's, oh my god, where did that hour go? So yeah, another good evening.
It's been brilliant.
Okay, well, thanks very much, Craig, for your help and support, and thanks to everybody who contributed in the chat. Please keep doing that, and hopefully we'll see you again in a week.